So even when we have variables involved here, as long as we can keep track of the times and divide pieces or the factor pieces, we should be okay. So here we need a common denominator again. So the denominator is missing a factor of 8 here, a factor of 8 here. Here we're missing a factor of 5 and a factor of 5. So we end up with 8a over 40 plus 35a over 40. Now the denominators are the same, so we can add the numerators. The numerators are like terms, so we can actually combine them. So we end up with 43 over a over 40. Now we don't know what a is, but we kept track of our factors, and so we know that this must be correct. Here this is times, so this is all just one fraction. Times on top, divide on bottom. Okay, we combine all the times and all the divides. So here we need to, if I want to multiply this, I have to do the brackets first. Now, it's kind of hard, so there's a couple ways I can do it. I can distribute and see what I end up with. I can get a common denominator here and make this into one fraction. I think maybe I'm going to try that. Now, I can't say that one is better than the other. If you're more comfortable with distributing first, that's okay. But I'm going to make this a common denominator and make this 2a over 2 and then minus 1. So now this is just a fraction of times on top, divide on bottom. So when I work this out, all I know is that the numerator doesn't change because it's times by 1. And again, remember that's a factor. That whole thing's a factor. And the denominator, I'm going to combine my divides as divide by 10. Okay, so what's my common denominator? Now we can ignore the numerator for now. We just want to get a common denominator. That's our priority. So I need a times 3 here. Balance it with times 3. I need a times 2 here and a times 2 here. So I end up with 2a over 30 plus, this is distributing, so 6a minus 3 over 30. Well, I have a common denominator. I can then add the numerators, and when I add the numerators, I just combine only the terms that are like. So 8a minus 3 all over 30, and then I'm done. Since 3 is not a factor, we cannot cancel factors here, because that's, once we get pluses and minuses in there, that whole thing becomes a factor. So we can't just treat that 3 by itself. Here, there's a few things we could do. We can make this into one fraction on the bottom. We can make this one fraction on the top and then divide. Okay. I kind of would like to get rid of these fractions though. And I know that if I balance the fraction, I can, so when I talk about getting rid of the fraction, I'm talking about the complex fractions, the embedded fractions. And what I do know is if I times the top by some number and the bottom by some number, I keep this ratio the same. And if I times the top by a factor of 5, and I times the bottom by a factor of 5, I keep it balanced. If I times the bottom by a factor of 2 to get rid of the divide 2, and times the top by a factor of 2, I keep the fraction balanced. So what I'm going to do is this. I'm going to multiply by 2 and 5 on top, and 2 and 5 on bottom. Now, by doing so, I've kept the fraction ratio the same. But now, I have something that's going to get rid of this embedded fraction of divide by 5. And I've got this 2 here, which is going to get rid of that embedded fraction of divide by 2. So this is a strategy I can use. So I end up with 20a, so 10 times 2a, plus the times 5 cancel, so I've got to remember I distribute here. Divide 5 times 5 cancel, I'm left with 2a. Well, that makes it a little bit easier to look at. Here I end up with 10 times 5 is 50, minus the times 5, and the times 2 and divide 2 cancel, so I end up with 5a. Now these are not like terms, so I can't combine them, but the top numerators are like terms, so I can combine the numerator into 22a over, and again, we cannot do anything with this denominator. As much as I want to, I cannot combine that. And that's it. There's my answer. I'm left with a binomial denominator.